I'm Dr. Mike Murphy. In this video, I'm going to discuss the network layer. The network layer is the third layer from the bottom of the OSI model layer stack. This is layer 3, and this layer operates on units of datagrams. So this is our basic unit of data transmission that we use at the network layer. A datagram is also called a packet. And what a packet or a datagram is simply a connectionless message. It's a short message sent in one direction without requiring any type of acknowledgement. So we send one of these datagrams from one place to another using the network layer, and we have no way of determining if it actually got there or not. We just kind of hope it does. Messages can come in several forms. Unicast messages are messages or datagrams that are sent from one device directly to another device. A datagram can also be sent from one device to all devices on the same subnetwork, and that's what we call a broadcast message. There's yet another type of messaging called multicast messaging, which allows messages to be sent from one device to a set of devices that listen for them. And this set of devices that listens for the multicast messages have joined multicast groups. So we have these special multicast groups. A system can join it and receive multicast datagrams. Within the network layer, we deal in concepts of subnetworks. So a subnetwork is a network segment, but at the network layer. So a network segment is a concept that we bring up from the physical and data link layers, sometimes also known as a broadcast domain, or a subnetwork or subnet. And the purpose of the network layer really is to take all of these different subnetworks, which you can think of as isolated units, and link them together by forwarding datagrams between them. Within an individual subnet, the data link layer does most of the heavy lifting, so it does most of the work within the subnetwork for getting messages from one point to another. But in between those individual subnetworks, the network layer kicks in and forwards the datagrams. And it does this by a technique that we call routing. And routing is the act of forwarding the datagrams between subnetworks. Routers use special software. Notice I have software emphasized here. So here I have two subnets and two routers. It is the routers that are connected together, and each router serves a subnet. Now you might be thinking, well, I have a router at home. Okay, here's a classic old router, a Linksys WRT54G. That's a router, right? Well, yes, okay, that's what we call that consumer device. But in reality, what that consumer device is it's actually a small computer. And this device contains the router software. So this is a little mini computer, embedded device, that runs the router software that enables the routing to occur. It is still a software operation fundamentally to get packets routed. It does not require a special piece of hardware. Any computer with the right software installed can route packets. Now, the most common network layer protocol that we use today is the Internet Protocol, or IP. And a datagram in the Internet Protocol, or a packet, consists of a header followed by the payload. The payload is the data that we would like to transmit. We have two versions of the Internet Protocol in use today. IP version 4 is the most widely used still, and it was first deployed on ARPANET way back in 1983 and is still with us today. It uses 32-bit addressing, which has proved to be limited as the number of devices that we have has exploded. The version of Internet Protocol that is becoming more widespread today is IP version 6. This was standardized in 1998, but it's only now starting to see widespread deployment, particularly in Asia. This version of the protocol uses 128-bit addressing and provides enough IP addresses for every device on the planet, at least all the devices we have now and think that we're going to have in the near future. So we have both of these versions of IP in use, and these are both examples of network layer protocols.